Hello and welcome back. This is a new section over geometry, and this is section 3, and this is called area of a circle and a sector. Now, I don't really like to use the word sector. Okay, I like to think of that as my pizza slice. Okay, so a sector is like a pizza slice. Okay, allows us to, take the area of a circle and find the area of a portion of that circle. Okay, so what I know here is that the area of a circle is given to us by the formula A is equal to pi times the radius squared. Okay, and so remember the radius is your distance from the center of the circle to the outside of the circle, and you have a number of radiuses. Okay, and also remember that the radius if you have a diameter that's equal to 2 times the radius. So if you wanted to solve for your radius is really just your diameter divided by 2. Okay, so let's go ahead and let's take a look at a couple problems of solving problems involving area. So what we have here is we have a water fountain with a circular base, has a radius of 6 feet, okay? And so I'm going to draw that picture of a fountain, okay, with a radius of 6 feet. So 6 feet, all right? And that fountain is surrounded by a circular path that goes around, and this has a length here of 2 feet, okay? And so what we want to do is we want to find the area of the path alone. So we want to find the area of this portion here on the inside, okay? So let's go ahead and take a look at something. Okay, what I want to do in order to find the area of this like circular piece here, okay, kind of like a ring shape, okay, we want to calculate the area of the ring shape. So calculate area of the ring, okay? And so with that, what I want to do is I know I can find the area of the total area with the big circle and the little circle, and then I could subtract out the small circle, okay? So let's do this. So to calculate the area of the ring, that would be equal to the area of big circle minus the area of the small circle. Okay, leaves me with what's in between. All right, so now what I have, let's find the area of the big circle. Okay, so let's do, I'm going to zoom in here, and let's do area of the big, okay? And so the radius for that would be a total of 6 and 2 added together. So my radius is equal to 8 feet. All right. So my area then is equal to pi times 8 squared. All right. Now what I'm going to do is I'm going to leave this in terms of pi, and I'm going to write this as area is equal to 64 times pi. Okay, and that's going to be feet squared. Okay, we'll leave it like that just for right now. Okay, let's find the area of the small. Okay, area of the small circle. Okay, and my radius for that is equal to 6. Okay, it's this small circle here. Okay, so my radius is 6 feet. Okay, and I want to use my formula and say that area is equal to pi times 6 squared. Okay, which is going to give me an area of 36 pi, and that's feet squared. All right, so that's what I've got for that. All right, so what I want to do in order to find the area of the ring, okay, so area of the ring, okay, just like I had over here, we want to find the area of the big circle minus the area of the small circle. So I'm going to do this. My area, okay, for my ring is going to be 64 pi minus 36 pi. And when I do that, what ends up happening is I kind of treat pi like a variable, and I'm just going to subtract 36 from 64. So if I do 64 minus 36, that's going to give me 28. So my area is equal to 28 pi, and that's feet squared. Okay, now this is an exact answer. Okay, now we can get an approximate answer by taking 28 and multiplying it by pi, and that's going to give us an approximate area of 87.96 feet squared. So 87.96 feet squared. Okay, so this is an approximate. Okay, all right, let's move on and take a look at the next one. Calculating area. So what we have here is we have an individual head of a sprinkler system covers a circular area of grass with a radius of 25 feet. The yard has 3 sprinkler heads that each cover a circular area with no overlap. So what is the approximate total area that will be watered? So what we have here is we have 3 sprinkler heads that cover a certain area. So I'm going to draw this area here that they don't overlap. Okay, and so if I have 3 sprinkler heads, each with a radius of 25 feet, okay, putting that in here, okay, 25 feet. If I wanted to find the total area, okay, so let's write this. The total area can be found by calculating the area of one circle, calculating the area of one circle, then multiplying it by 3. Then multiplying it by 3, okay, because there are 3 of them. All right, so let's go ahead and do that. So what I have is I have my area here. My radius is equal to 25 feet, okay? So I'm going to plug it into my formula, pi times 25 squared. All right, and 25 squared is going to give us 625, I think. 25 times 25. Wait, no, hold on. 25 times 25. 625. So my area is equal to 625 times pi, and that's in feet squared. My units are in feet squared. Okay? And so now what I want to do to find the total area, okay, the total area, this is just the area of one. Total area is going to equal 3 times 625 times pi, and that would be feet squared because I have 3 triangles, 1, 2, 3, okay? So I'm going to take that number, multiply it by 3, and that's going to give me an area of 1,875 times pi feet squared, okay? And so if I take that and multiply that by pi and get an approximate answer, my area is approximately 5,890.49 feet squared. Okay. Now, both of these answers, okay, are correct. Okay, it didn't tell us how to round. But this value here is exact. Okay, taking 1,875, multiplying it by pi, that's an exact number. And when I multiply it by pi and round it, this is an approximation. Okay? So, you know, be cognizant of that and be aware that that you know you might see those. Okay, next page. Okay, so what we're really trying to get into here, that last page is kind of a review on what the area of a circle is, and what we're talking about in these these 2 sections that we did, the last one and this one. We talked about arc length and sector area, okay? Now, an arc length is a portion of the circumference. So we took a portion of that circumference, and the same thing here, for a sector, it's a portion of the area, okay? So when we talk about sectors of circles, a sector of a circle is a region of a circle bounded by 2 radiuses and their intercepted arc, okay? So we have 2 radiuses here, a central angle, and we have an arc, okay? And instead of calling it a sector of a circle, I like to call it the pizza slice, because that's really what it is. Okay, so we have a pizza slice. okay? And so, we have these two radiuses here, okay? And we have this angle here, theta, that we're going to have to know, okay? So theta is important, if I can draw it right, okay, in this. All right, we'll be able to calculate this area that's inside of here, okay? All right, so let's take a look at how we would do that, okay? So, what I know is that the area of a sector of a circle is found by multiplying these two factors, the ratio of the central angle over 360 degrees and the area of the entire circle, okay? So what I'm going to do, let's just call this angle here 90 degrees, okay? And let's call this radius here, I don't know, 2 feet, okay? So what I would do, all right, if I wanted to find the area of this, what I would do is I would take the area of the entire circle, okay? So my area would be pi times 2 squared. So my area of the whole circle would be 4 pi. Now, I know that my sector area is going to be 1/4. So this is 1/4 of the whole circle. Okay, and how do I know that? I know that because my total degrees in a circle is 360 degrees. So if I draw in this whole thing of 360 degrees, okay, I'm taking 90 degrees of that 360. Okay, so my portion of that becomes 90 degrees divided by 360 degrees. Now, this is equivalent to 1/4. Okay, so what I would do to find the area of my pizza slice, the area of my sector, is I would take 90 degrees divided by 360 degrees and multiply it by the area of the circle, pi times 2 squared. Okay, and so what we would end up getting, interestingly enough, is that I would get 1/4 times 4 pi. The 4's divide out, and my area of my sector would just be pi feet squared. And I think that's why they call it a pizza pie. I don't know. I made those numbers up. That kind of just was a coincidence. Okay, so let's take a look here. All right, and that's what we get here. So x degrees. Okay, when we have this formula, area of a sector, this is the formula that we want to use. Okay, x degrees is your central angle. Okay, central angle, and then r is your radius. Okay, so over here, let's do an example here where we have a central angle here. Theta is equal to 135 degrees. And also, they use this thing up here with theta. You can also use theta degrees over 360 degrees times pi r squared. Okay, same thing. Okay, it doesn't matter. Just as long as you identify that this is your central angle. I'll typically use theta because, x is commonly used with other variables. Okay, and so then my radius is 16. All right, so what I'm going to do is this. In order to find my area of my pizza slice, okay, and this would be a pretty big pizza slice, and Lord knows I love pizza, okay, I would say that my area would be equal to 135 degrees divided by 360 degrees, and then I would multiply that by the entire area, which would be pi times 16 squared, okay? Now, 135 divided by 360, well, let's just do this, okay? Using your calculator, and you're going to want to use your calculator for this, what I think about is I think of, if I'm multiplying this fraction by this number, I think of this as over 1, okay? And I'm just going to multiply across. So what I end up getting is I get 135 degrees times 16 squared. Now, 16 squared is, let me figure out what that is. 16 times 16, 16 times 16 is 256, okay? And then multiply that by pi, and then divide that whole thing out by 360. Now, you can kind of simplify this however you want, but I'm going to do 256 times 135, okay? And this is going to give me 34,560 times pi. Divide that by 360. Okay, I can divide this number by 360, and it gives me 96. So my area is equal to, end up being 96 times pi. Okay, so you can kind of multiply, I multiplied this number and this number together to get this, and then I can divide these out separately and leave that in terms of pi. Okay, and this would be units squared. Okay, now if I wanted to actually evaluate that, I'd multiply that by the number pi, and that would give me an area of the sector of being 301.59. And that's units squared. Okay, again, what I know is that this is my exact answer, and this is my approximate answer. Okay? All right, let's take a look at another one. It says, what is the area of this shaded sector? So what I know is that my angle measure, theta, is equal to 45 degrees, and I know that my radius, r, is equal to 24. Okay? So using my formula, and I'm going to write my formula down again, area is equal to theta divided by 360 times pi r squared. Okay? So what I'm going to do, area is equal to theta, which is 45 degrees, divided by 360, times pi times r squared. Or I'm sorry, let's plug in 24 for that, 24 squared. All right, now 45 over 360, if I divide each of those by 45, if I think of that fraction 45 over 360, if I divide this by 45 and divide this one by 45, I'm going to end up getting 1/8 out of this, okay? Because 360 divided by 45 gives me 8. Okay, so this can be rewritten as 1/8. So if you recognize that you can simplify fractions, go ahead and do that. All right, so my area is going to end up being 1/8 times pi times 24 squared. So 24 times 24 is going to give me 576. Okay, so let me rewrite this as 576 times pi all over 8. Okay, now let's see if 576 and 8 divide out. So let me divide those two. Ooh, look at that. We're going to get 72. So area is equal to 72 times pi. And I got 72 by taking 576 divided by 8. Okay, now if I multiply this by pi, I'm going to get 226. So my area, let me write this over here. Okay, my area is going to equal, or is going to be approximately 226.19, and that's units squared. All right, so this is my approximate, okay, and this is my exact, okay, this is units squared. All right, and that's that. Okay, so just a couple practice problems. So let's take a look at the next page. Okay, on these next two examples, what I have is calculating the area of a sector given radians. Okay, so radians, remember, is a different measure. It's just a different way of measuring an angle. Okay, so what we have is this new formula here. Area of a sector is equal to theta over 2 pi. And that's, we multiply that by pi r squared, okay? So it's the same idea. Remember that, when we talk about degrees versus radians, let me write this up here. Degrees, you took your angle theta and divided it by 360 degrees, okay? But if you're talking about radians, it's the same idea, it's just that your number's a little bit different, okay? Radians, you're doing theta out of 2 pi. Okay, because remember that 2 pi and 360 are the same thing. All right, and that's all we're doing. All right, so let's take a look at this one. So a little bit more practice. I know that my angle theta is equal to 2.2, and I know that my radius is equal to 8. Okay, so let's calculate the area here. All right, so what I have, and let's just plug it in. Okay, so my area is equal to 2.2 radians divided by 2 pi radians, the whole thing. And I'm going to multiply that by pi times 8 squared. Okay, now this is going to take some heavy-duty calculator stuff. So let's do 2.2, that number, times 64, times pi all over 2 pi. Now, the cool thing about this one, you really don't need that much of a calculator. We can divide some things out here. I know that pi and pi are going to divide out. Okay? I also know that 64 over 2 simplifies to 32 over 1. So my new area then becomes 2.2 times 32. Okay? So if I take 32 times 2.2, let's do that. 32 times 2.2 is going to give me an area of 70.4. Okay, so my area is equal to 70.4, and that's units squared. Pretty nifty. Okay, let's see if that same concept will work in the next one. Okay, so over here I know that theta is equal to 3 pi over 4. Okay, and then let's actually, it may not work for this one actually. And then my radius is equal to 5. Okay, so let's see what we can do here. All right, so now I've got that my area of my sector is equal to theta, which is 3 pi over 4. Okay, and that's all being divided by 2 pi. Okay, and then we're going to multiply that by pi times our radius, which is 5 squared. Okay, so this is a little tricky because we're dealing with fractions within fractions. Okay, so kind of a quick review on that because you will encounter this. 3 pi over 4 divided by 2 pi. Okay, let's rewrite this. Now, dividing by a number is the same thing as multiplying by its reciprocal. So I could rewrite this. So I could rewrite 3 pi over 4, and I'm going to multiply that. So instead of dividing by this number here, I could multiply by its reciprocal, which means I would multiply it by 1 over 2 pi. So going from this step to this step is very important, okay? And then I'm going to multiply that by pi times 5 squared, which is 25, okay? So now what I notice is I can divide these pi's out, okay? I still have 1 pi left over, okay, and that's all right. So let's do this. Let's do, I'm going to put all this over 1. Okay, and so then my area, then I'm just going to multiply all my numerators together. So I've got 3 times pi times 25. Now I can do 3 times 25 to give me 75, and then multiply that by pi. And I'm then going to divide that by 4 times 2, which is going to give me 8. Okay, now 75 and 8, those aren't going to divide into each other. So we can leave it like this, okay, and this would just be units squared, and this would be your exact answer, because you can't simplify anything any further. However, you could still then go through and multiply this out to get an actual number. All right, so let's do that. So if I did 75 times pi, all right, hold on. Let me do... All right, so if I did 75 times pi, it's going to give me roughly about 235.62. And then if I divide that by 8, that'll give me a better approximation. So let me divide that by 8. And that's going to give me an area of my sector to be 29.45 units squared. Okay, and this is approximate. All right, so this is exact. This is approximate, okay? And that's it, you know? And so I hope you enjoyed this video. I had a lot of fun making it. I like these types of problems. I think they're really fun. And it's really not that big, that hard of a concept, I don't think. So, you know, go ahead and give the homework and quiz a try, and we'll see you in a bit. Thanks. Bye.